So I've recently joined DARE as CI, and my background is sensors, but as DARE is mainly on data analytics, so I thought it will be interesting to tell about my background so that it will be useful in future so that I could get involved much more with the DARE activities. So I have made the title IoT Enabled Sensor to generate data for health, home, and environmental conditions. So just about me, as Travis already told, so I am with Macquarie for last 5.5 years. I'm originally from India. I spent 5 years in Japan and 16 years in New Zealand. So we basically develop different types of sensors. Sensors are very important for any system. And if we want to improve something, we need to know what is the current value, and that's what sensor gives us. Lord Kelvin told that if you cannot measure it, you cannot improve it. For measurement of any parameter, we actually need sensors. So I don't want to go to the definition of that, but we use the term sensors, transducers, actuator, transmitter, and stimulus for making any sensing systems. Especially if we want IoT-enabled system, we need the transmitter, wireless transceiver for making a system. Here at Macquarie, we do research on sensors in 2 different ways. If students do finally a project or masters through research for 1-year program, we actually develop sensor system using the sensors which is readily available. So as I show in the left-hand side. But if my student, they do PhD, we usually develop sensors either from MEMS-based or in recent time, flexible material-based. Usually we find nice applications and we try to develop sensors to cater that applications. And once we develop the sensors, then we make the sensing systems. And our aim is to upload the data into the cloud. So the sensor become Internet of Things enabled sensors. And that helps us to access the data from remote locations. Of course, in Sydney, these days, last 3-4 years, we can see there are different gateways, especially LoRa, long range wide area network. LoRa gateway has been installed in many places. So that gives very long range and helps us to upload the data into the cloud. I'll talk a little bit on the health monitoring aspect of our project. So we develop sensors based on MEMS technology, and our sensor is basically called interdigital sensors. They are actually capacitive type of sensors and very important for characterization of any kind of dielectric material, whether any type of food item, whether any type of juice, water, and so on. So this is the MEMS-based sensor we can fabricate, and it can even go to very low resolutions to detect a cancerous cell. So we developed the sensor in the 4-inch wafer, and one 4-inch wafer gives us around 35 sensors. Each one can be 2.5 millimeter by 2.5 millimeter sensing area. Then we make the sensing system using this sensor as the element which is detecting the parameter of interest. For characterization, we use standard system. So one of these is the LCR meter, inductance, capacitance, resistance, and we characterize the sensors. And this sensor basically gives us what is the capacitance value as a function of frequency, as well as a function of the concentration. One of the applications is that we can detect the pathogen, especially E. coli bacteria in meat. Another applications we have done is that how much phthalate is leaching from plastic bottle. So that has some health implications. So we can detect like up 2 parts per billion. For selective detection, we make our sensor selective by providing a coating on the top of the sensor surface. So the coating we develop called molecular imprinted polymer. So it's a polymer which comes as a layer on the top of the sensor surface. And that gives us many advantages. We can actually store it, and it provides also harsh application in the harsh environment. The polymer preparation takes time around 48 hours, and it should be selective to a particular molecule which we want to detect. These are some experimental results on a particular applications where we want to detect early stage of osteoporosis. And this polymer, they actually selectively detect that C-terminal telepeptide protein molecule, and we can compare whether we can use this polymer or without polymer. And then we can upload the data into the cloud so that anyone who is the close relative or maybe doctor, they actually can see how is the change of that particular system with time. So a few years back, we were thinking of something like this type of system, sensor system. The array of sensors can be installed in the toilet where we do not need to collect the sample, but it will be automatically measuring the parameters along with the CTX1, which is C-terminal telepeptide, which is one of the parameters for telling the person is having early stage of the osteoporosis. We also need to measure creatinine and calcium, and this data will be uploaded into the cloud. That was the idea. So whenever we develop sensor, our aim is that it will help us to make the lifestyle much safer and better. So the big picture is called smart home, which provides a safe, sound, secure, and independent living environment. The reason, of course, is that compared to earlier life, 20, 30 years back, lifetime of the people have extended considerably. Now many people are 100+ years old, but when people become old, they become fragile, they fall down, and actually they need help for their day-to-day activities. But there is also another issue that sometimes even people are not old, they live alone. Some unforeseen incident can happen and people have died, but that death news has not been received by any close relative for days and weeks. If we see the statistics, almost 35% people, both men and women category, they live alone. So our aim is not only to cater the people living at old age, but also living alone, but they want an independent lifestyle. At the same time, there are technology which is actually monitoring. That's what the idea. We started this research almost 16 years back using the sensors, wireless sensor network, and later on then Internet of Things. What we try to do is to monitor the parameters which are used by the persons as a part of the daily life. And then on real time, those measured data are uploaded into the cloud or even into the server, and then we process the data. And that's where the data analytics comes into picture here. So we have developed different types of sensing systems which can come as wearable sensors for monitoring physiological parameters, also non-wearable sensors, which is used at home to monitor different activities. So we applied our systems in a very old home. So it's a 2-bedroom house. And those systems are installed at different part of the house to monitor the different activities of the person living alone. So this sensor can be electrical sensors for monitoring different electrical appliances, force sensor for monitoring chair, sofa, bed, and also PIR sensors, which monitor the movement of the persons. There's the volunteer living in the home, and sensor monitors different activities. So effectively, the home, which is an old home, become a smart home with the help of technology and sensors. We collect the data, raw sensor data with time step, real time, and then all the data are stored and they are analyzed to monitor different activities of the persons. From the activities, we can talk about person's wellness, how well the person is living his life. So here, once we have the sensor installed and collecting the data, everything becomes software, everything becomes data analytics. So we develop different types of software which is annotating the activity. We also apply some kind of probabilistic approach. We apply the data time series data analytics. The whole idea is to find what is the behavior of the persons. And when we say the behavior, it's basically how well the person is living his lifestyle. Now, person's life can be very complicated, and persons, they may be different from each other. So it is important what type of sensors are useful for somebody's life to monitor the different activities. So we develop a basic systems, and then we apply mathematical tools, frequency of sensor usage, to see which sensors are important, which sensors are not important. If a sensor is not used at all with a duration of 1 week or so, we may not include that sensor for the final setup. And from there, once the sensor decided and they are used, we can take what are the activities the person is doing from the sensor data. And then we can define the wellness, how well the person is living his lifestyle. So we define two wellness functions. One wellness function is based on inactive usage. So there may be a time when the person is not using any kind of sensor for his day-to-day life. So that is a time where there is a huge possibility some unforeseen thing can happen. So it starts with 100%, and then with time it reduces. This value, wellness function value, will tell us when there is a need of generating a warning message. So if it is become 50% or 60%, we can put that threshold value to generate a warning signal. Another function, wellness function, is based on excess usage. This is very important. So suppose sometimes we see that person is doing some activity which is taking more time. For example, person is sleeping. Normally we can assume that person sleeps maybe 9 to 10 hours, but on a certain day, person is sleeping more than usual. So something might have happened. Person may not be feeling good, or maybe some other bad things happen. So that is another issue this function can tell us. So using the data which we collect, we actually use 8 weeks of old data. We can forecast what can be the person's lifestyle for the next week. So what happened when we install the system, then with time, person lifestyle changes. So that's why the forecasting is very, very useful. This forecasted data is used as the regular data, which is compared with the actual data to find out any kind of irregular behavior. So here we use the time series analysis to get the next week of data, which is assumed as the reference value. So we have compared the predicted value with the actual value, and we can actually tell how the person's lifestyle is changing with time. So we can actually predict the person's lifestyle and person's certain activity based on the last 8 weeks of data, or even we can take more weeks of data. And here we take the seasonal variation, because when we see the weather changes from winter to spring or spring to summer, we take into account that factors for the forecasting. And that's very, very useful for using the data as the reference data. The PIR sensor tells us that where is the person inside the house, and we can use that PIR sensor data to find out where the person is located and whether some abnormal things can happen or person has fallen down and so on. So that's also very useful for monitoring the persons living at a home independently. I'll talk about another project which we have recently finished. It's on smart city project. So this project was 2019 to 2020, 2 years. We count the number of pedestrians on road, as well as we monitor some environmental parameters. Here we use the PIR sensors. Before selecting the PIR sensors, we had a very long discussions whether we'll use camera or RFID tags or Wi-Fi reader. We have some consideration. The system should be low cost. It will also not consume power too much. It must provide the detection ability, and also it will not intrude the privacy. So based on this condition, we use the PIR sensor, passive infrared sensor. There are quite a few projects happened in recent times in Australia, Melbourne, as well as Liverpool, also in some other part of the world, like in New Zealand, Auckland, New York, and Ireland, Spain, Barcelona. So many people use this pedestrian count as the project, and they use either PIR sensor or camera. Many people use video camera as well as thermal sensor. In terms of the communication technology, people use either 3G or 4G. We have used LoRa, long distance network, wireless area network, wide area network, and of course the power and other things. Now, interesting thing is that most of the system they actually install on the electric pole so that the installation cost can be reduced. So we have modified the PIR sensor to a certain extent to change the focus distance to suit our need. And we have made it such a way that from the ground up to 1 meter, we will not be counting anyone. So if somebody goes with pet, we will not be measuring them. So PIR sensor, of course, a low-cost sensors. It's based on the movement as well as body heat, and we have modified the normal available sensors in the market to suit our need. And we also have used ambient monitoring system with environmental combo to monitor few parameters such as temperature, humidity, pressure, carbon dioxide, and total volatile organic compound. So all these sensors are readily available, and we just configure them. We interface them around a microcontroller to collect the data every 10 minutes. So this system is powered by rechargeable battery, LiPo battery, 3.7 volts, 6,000 milliampere hour, and we use a solar panel to charge the battery. If we do not have any sunlight for consecutive 4 days, we can still operate the system up to 4 days. That's the electrical circuit where we have got all the PIR sensor, environmental combo connected to our microcontroller, and then microcontroller is powered by the battery. Now here we have done a little bit of intelligent algorithm. So what happened if we have people walking on the footpath and the PIR sensor, the system is installed, the electric pole, person comes on the focal length. So we will measure, we'll see a change of the signal, but it might happen that this signal stays almost like just under 1 second. If within the time, if another person enters, the width of the pulse increase. So then we have to consider the multiple people. So we have developed a little algorithm here to take into account how many people are actually passing through that region. So that gives us some kind of accuracy in the measurement. So for the power calculations, we can actually see the battery gives us around 4 days. So when we do not have any sunlight, we can have 4 days consecutive operations. So the system we developed, we started with making the 3D print, but later on we had to change. So our systems for the initial systems was like that. And then we installed the system around the Macquarie University, Macquarie Park area. Almost 74 nodes were used. Unfortunately, we had to take out due to the COVID last year. There was no maintenance. So the system has been taken away last year. Our architecture was that sensor node monitored count the people and monitor the ambient parameters, and every 15 minutes, it uploads the data using LoRa gateway to the cloud. The LoRa gateway, interestingly, in Sydney, they actually, not all, but in Macquarie Park area, they owned by a company called Mesh Network. So the data goes to them, and then we actually use the data from their system by developing the apps and API. So even though the data goes to them, but we can actually use the way we like. And then we can develop the program for the visualization. Either we can see in the computer or laptop or the mobile phone. So these are the pictures where when we have the sensor installed in the Waterloo Road, Herring Road, here near in the Macquarie Park. Later on, we changed the 3D printing design using the normal available JECA electronics, some boxes. So we have installed the system inside the JECA box, and the battery, electronics, the PIR sensor, temperature, humidity sensor, and so on. And they're installed on the pole with the solar panel along with the sensor. So interestingly, this installation also quite difficult, because as we all see that the road is quite busy. We cannot do it in the daytime. So we had to help from a professional company, and they usually come in the night time after 10 p.m. To install, to do any kind of maintenance. So it's a big problem for having this type of project and how we can actually make sustainable for long term. So these are the different places where we had our sensor node installed in the Epping Road, Waterloo Road, Herring Road, Talavera Road, and so on. So all total, we had 74 nodes installed, and they worked for 2 years. And we have collected huge amount of data. And these data are time resolution is around 15 minutes. Of course, the spatial resolutions, that is dependent on the place where we want to monitor and what we want to monitor. So spatial resolution is not an issue, but the time resolutions was 15 minutes. In the beginning, we had to validate the system. So what we did, we actually counted the number of people manually, and also the system, what it gives. And from there, we actually had to develop some kind of algorithm to make the accuracy better. So here we have compared the actual measurement with the measurement given by the system. And as we can see here, depending on the time, we have accuracy error which is going between 3% to 9%. So by introducing some kind of algorithm here, we actually can make the accuracy better, and it goes to almost 99% accurate. So these are some data which is coming from the collected data in the server. So we can see the people's movement, directions, as well as the environmental parameters. And then we can actually use that data to show different types of heat map, how many people in a certain area at a certain time. And also we can compare hourly data with the weekly average data for a particular day at particular place. these are all, of course, after we get the data, we can do all this analysis because we have now the data available. We try to see whether there is any kind of relationship between the people's movement and the ambient parameters, but it is very difficult to find the relationship because people go out without considering what is the ambient parameter because we have to go for the job. So it's very difficult to correlate how the people's movement related to the ambient parameters. But one interesting observation, what we have seen that, as we all know, that last 2 years during the lockdown, sometimes we are not allowed to go out. So on a specific day during lockdown and not lockdown, we actually can see a significant change. As we all see that during lockdown, number of people on the road is considerably less. But also interestingly, you can see in the night time, there are some movement of the people on the road. So that's very, very interesting observations. So this is something which we actually can see. And in order to see the accuracy of the system, we have taken 2 points where the data should not be different. The number of people going at that particular portion of the road must be equal because there is no other road coming out. So this shows that the 2 results is pretty similar, and that says that the nodes are working. Of course, the electronics node, they need maintenance time to time. So that's another important things we have to keep in mind. And then we have developed a visualization software. Depending on, we can see either in mobile phone, or we can see in the laptop, or we can see in the desktop computer. So I will stop it here. So basically we generate data through the sensors. So we develop different types of sensors, and whatever sensor we develop, we try to make them IoT enabled. So the data will be available in the cloud. And then of course, we can use the data to analyze depending on what we want to show. So that's the important thing. And we develop sensor both for human health as well as environment, as well as healthcare applications. So the recent project, what we have finished in Smart City, that we have done very well, and it was working 2 years, and we have huge amount of data. So I would be happy to share those data if anybody is interested. And also we also recently developed some sensors for another project, where is all water, with few other universities together. So that's also currently going on. So we develop sensors which are generating data for different applications. So I finish here, and I will be happy to take any questions and comment